Is it well with you, my dear students? My names are Mr. Naftal Lucas Makumbire from Premier Girls Secondary School located at Kromo, Bagamoyo. I'm teaching chemistry in advanced level, Form 5 and Form 6. Today, I'm here to present it to you one of the most interesting topic, and this topic is energetics. Or in other words, this topic is called thermochemistry. Thermochemistry. This topic is very, very important. I hope that, my dear students, you have discussed this in your class, so there is no problem with it. Even if I ask you right now, what is all about this topic? What is all about energetics? I'm sure that where you are, you have the skills of answering, what is it all about? Can you ask yourself, what is energetics? I'm sure that you know. It is concerning with the heat change, measurement of heat change, which are occurring during a chemical reaction. But this topic covers mostly two subtopics. Subtopic number one is heat of reactions. That is subtopic number one. Subtopic number two is Hen's law. These are the two subtopics which are covered in this topic of energetics. Now, today we are going to deal with the second subtopic of this topic, which is Hen's law. In this Hen's law, there is application of the application of this law involves three most areas. Hen's law application involves determination of enthalpy change using three important areas. Number one, using thermochemical equations. Thermochemical equations. Number two, bond energies. And number three, Born-Haber cycle. So those are the three areas that are concerning with the application of the law. But today, specifically, we are going to deal with the first part of it, the first application of it, and automatically that is thermochemical equation. So our today's discussion will be based on the thermochemical equation. Thermochemical questions. Now, you can ask yourself, why are you giving us this subtopic? Or why are we discussing this subtopic today? You know, there are so many challenges that most of the students are facing when solving the problems relating with the application of Hen's law using thermochemical equations. And most of the students are facing the problems because they are lacking some skills which can help them to solve those problems. That's why today, I have to share with you on how to be competent to utilize concepts, skills, and principles in solving different problems in chemistry, in various activities and practicals. You can also use chemicals, symbols, and formula to communicate in chemistry life. Now, my dear students, my dear students that are watching right now, thermochemical equations, I'm sure that you are able, if I ask you, what are thermochemical questions? I'm sure that you can be able to tell me the definition. But today's ways of asking questions, the new format, are competency-based questions. Sometimes you might not be directly asked to define thermochemical equations, but you can be given a chemical equation. For example, if I give you a chemical equation right now on the board here, hydrogen gas reacting with a half oxygen gas to give water, which is a liquid. And the enthalpy change for this reaction is equal to negative 286 kilojoules per mole. That is a thermochemical equation. Now, if I tell you to define thermochemical equation regarding with this example, how are you going to define it? It is very, very important because sometimes you can be told what is the general term used to describe this equation. It is a thermochemical equation. So from here, we can say thermochemical equation, these are balanced chemical equations which are written together with the enthalpy change. As you can see, that means when oxygen gas reacts with hydrogen gas to get water liquid, the enthalpy change for this reaction is negative 286 kilojoules per mole. But my dear students, because remind you, I want to recall you back to the introduction of this topic. Energetics is all about heat change for the chemical reaction. Now, there are two types of reaction involving heat change. I'm sure that you know. If I ask you to mention the two types of reaction involving heat change, I'm sure that you are able to mention. Even there you are right now, I'm sure that you are just telling me what are they. We have endothermic reaction and exothermic reaction. Now, these two reactions are very, very important because endothermic reaction, these are the reactions which occur by absorbing heat from the surrounding. But exothermic reaction, these are chemical reactions which are taking place by releasing heat to the surrounding. So it is very, very important whenever you are given a thermochemical equation, it is very, very important for the enthalpy change to be indicated either the negative sign or the positive sign. The negative sign indicates that that reaction is exothermic. That means energy is given out. But the positive sign indicates that reaction is endothermic. That means energy is absorbed from the surrounding to make the reactant to react from the products. I'm sure that, my dear student, you are following. Now, this is one of the examples of the thermochemical equation. Now, we can be asked some different questions to find the enthalpy. The main thing here, to determine the enthalpy change of the reaction using thermochemical equations. That is very, very important, my dear students. Now, if you are given the questions, because I told you that there are so many problems, there are so many challenges about this, this particular part, especially on how to solve these problems. And I've told you that there are some little skills that most of the students are lacking in order to solve these problems. Today, I'm going to tell you those techniques that you can use. And I'm sure that when you follow this program up to the end, you're going to enjoy. And you're going not to miss any question that will come relating to this particular part. My dear students, when you are told, for example, to find the enthalpy formation, determination of enthalpy of formation using thermochemical equations. You know, determination of heat of formation of the compound can otherwise not be obtained directly. It is difficult sometimes to set an experiment to determine the enthalpy of formation of some compound, for example, methane and benzene. So it is difficult to measure the enthalpy of formation of these compounds directly, but we can determine the enthalpy change of these compounds, the enthalpy of formation of these compounds indirectly using Hen's law by using these thermochemical equations. Now, the way of asking different questions which are coming in examination, mock examination, pre-national examination, or annual examination, midterm examination, in national examination questions. There are different ways of asking these questions using thermochemical equations. Now, today we are going to deal one after another. Now, let me take you to the first example. The first example says, calculate the heat of formation of methane from the following data. From the following data. Methane, which is carbon solid reacting with hydrogen gas to give methane. From the following data. You have the data there. The first one, carbon solid burns in oxygen gas to produce carbon dioxide. The enthalpy change for this reaction is negative 393.7 kilojoules per mole. The second one is hydrogen gas burnt in oxygen to give water liquid. The enthalpy change for this reaction is 286.0 kilojoules per mole. The third one is methane burnt in oxygen to give carbon dioxide gas and water, and the enthalpy change is 890.3 kilojoules per mole. This is the question. Now, this is one of the ways of asking these questions. You can be given the required equations directly from the question. Directly from the question. So one of the ways of asking this question, the required equation, because here you are told to find the enthalpy of formation of methane. Now, you are already given the thermochemical equation. So you find the enthalpy change for that equation. So that is number one way of asking those questions. So you can be given directly. My dear students, let me take you back to the board here. Now, my dear students, let's solve that question that is given. Now, if you want to solve any problem like that one, the first thing that you have to do, now these are the skills that you have to apply in different equations that we're going to meet. And most of the students are lacking these skills. That's why I'm giving these skills. Number one, you have to write the required thermochemical equation. And it is already given in that case. So, the required solution to that problem, required thermochemical equation. Required thermochemical equation is there, given that carbon solid reacting together with hydrogen gas, two molecules, to give methane gas. Methane gas. Now, my dear students, do you remember when you were discussing about heat of formation in the class? When you talk about heat of formation, if I tell you to define it, because it is important to remember the definition of this term. When you talk about heat of formation, we are talking about the heat change of a chemical reaction when 1 mole of the compound is formed from its elements in their pure standard states. In their pure standard states. That's why carbon, the pure standard state of carbon is solid. The pure standard state of hydrogen is gas, and the methane is gas. I mean hydrogen. The elements which form this compound, methane, is carbon, which is solid, and hydrogen gas, which is a gas. Now, my dear students, so this is the thermochemical question. That equation should be balanced. You have to balance it. And of course, it is already balanced. That is number one way of asking these questions. So the enthalpy change of this reaction is what you are looking for. You don't know. Now, what are you given? Given, number one, you are given carbon and oxygen to get carbon dioxide with the enthalpy change, hydrogen gas and oxygen to get water, enthalpy change given, methane, oxygen, carbon dioxide, what? You are also given the enthalpy change for that reaction. So the question is very clear. Now, what you have to do, the skills number one I've told you is to write a required balanced thermochemical equation. That is number one, you've already done that. Now, the second skill, you have to manipulate the 3 given equations to get the required equation. So that means this required equation will be obtained by manipulation of the 3 given equations. So what are you going to do? Let's start with number one. Let's start with number 1. Now, in this given equation, the product is methane. The product is methane. Now, my dear student, when you go back to our equation there, to the 3 questions, among the 3 questions, which one has got methane? You can see a methane is found in the third equation, equation C, that we have methane gas and 2 moles of oxygen gas to get carbon dioxide and 2 moles of water. The enthalpy change for this reaction is given. But my dear student, in the required equation, methane is a product. But in the given equation, methane is a reactant. What are you going to do? That means we have to change that methane to be in the product side. So we have to reverse equation number C in order to make it to be in the product side. So here, reverse equation C. Why? In order to get methane on right-hand side. That is manipulation. So when we reverse, remember my dear students, the enthalpy change for the reaction is the same in magnitude, but different, but opposite in sign for the reverse equation. So if we reverse that one, that means the product will be the reactant and the reactant will be the product. So here we are going to get carbon dioxide plus 2 moles of water liquid to get methane gas and 2 moles of oxygen gas. The enthalpy change for this reaction will also change the sign. As I told you, Laplace law, I'm sure that you remember. So here it will be positive 890.3 kilojoules per mole. That is number 1. So it is very interesting. I'm sure that you're following, my dear students. Now we go to the second part. So the product is already there. So in the required thermochemical question that we're looking for, we have already methane on the product side. So there is no problem with that. Now let's come back to the reactant. In the reactant side, we have carbon and hydrogen gas. Now we go back to the 2 remaining thermochemical equations. We go back there. Which one? Let's start with the carbon. Which one has got carbon element? You can find it here. It is the first one. Carbon solid and oxygen gas to get carbon dioxide. So in the required thermochemical question, carbon is 1 mole. In the given thermochemical question, also carbon is 1 mole. So there is no need of doing anything. You just write it the way it is. So you write here, this will be equation. You write here carbon solid plus oxygen gas to get carbon dioxide gas. The enthalpy change of this reaction will remain as it is, negative 393.7 kilojoules per mole. That is very, very important. Now, we go to the last one. There is hydrogen. That is the remaining element. Now, the remaining equation is B, and it has got hydrogen. In the required thermochemical question, we have 2 moles of hydrogen gas. But in the thermochemical equation given, we have only 1 mole of hydrogen gas. The skills of solving that problem, what are you going to do? That means you have to follow what the required thermochemical equation wants. The required thermochemical equation wants 2 moles of hydrogen gas. So what you have to do, you multiply the given thermochemical equation by 2. That means the whole equation together with its enthalpy change by 2. So multiply equation B by 2. Now, hydrogen gas reacting with a half oxygen gas to give water liquid. The enthalpy change for this reaction will be equal to negative 286.0 kilojoules per mole. You multiply the whole of this equation by 2. So when you multiply, you get two hydrogen gas. 2 times a half. These two and these two will cancel. So we're going to remain with 1 mole of oxygen gas. 2 times 1 mole of water. We are going to get 2 moles of water, liquid. And multiplication. 2 times negative 286.0 kilojoules per mole. You just use your calculator. I hope that you have calculator because I'm sure that you are following, my dear students. So you take 2 times negative 286.0 kilojoules per mole. When you use your calculator, you're going to get negative 572 kilojoules per mole. So these are the data. So you have completed the elements and the product in the required equation. Now, the last skill, after you have manipulated, the last skill, you just add the equations that you have manipulated together with the enthalpy change. And that is the application of Hen's law. If I tell you to state the Hen's law, my dear student, I hope that you can be able to tell it because you have studied it. What is it? Can you state it right where you are? Summation. Hen's law of heat summation. Now, let's try together to sum this equation. Starting with the reactant for the first manipulated equation is this one. The reactants. You write the reactant for the first one is carbon dioxide. So here you add equations. You add equations. Now, the first one, carbon dioxide gas reacting with water, liquid. The reactant for the second part already. Now we go to the reactant for the second equation. This is carbon solid plus oxygen gas. We have already finished it. We go to the third one, hydrogen. We have 2 hydrogen gas and oxygen gas. So we have already completed all the reactants for the 3 given 3 manipulated equations. So we go to the products. The first product in the first manipulated equation is methane gas reacting together with 2 moles of oxygen gas. We go to the product for the second equation. That is carbon dioxide plus. We go to the third one, 2 moles of water. The enthalpy change as well, you add, you sum, and that is Hen's law of summation. Hen's law summation of enthalpy change. So you add. The first one, it was positive 890.3 kilojoules per mole plus the second one, negative 393.7 kilojoules per mole. Negative 393.7 kilojoules per mole. The third one is negative 572 kilojoules per mole. Negative 572 kilojoules per mole. All these are in kilojoules per mole. Now we have already done that. What do you do? Another skills. You cancel out those compounds which are present on both sides, reactant sides and the product sides. So let's check. Carbon dioxide, we have carbon dioxide on this side, 1 mole. And also we have 1 mole of carbon dioxide on this side. So what we do, these compounds will cancel out. We go to water. 2 molecules of water on the reactant side and the 2 molecules of water on the product side. So this one will go. Another one we have oxygen gas. But oxygen gas on the reactant side, we have 2 moles. We have 1 mole of oxygen gas and another mole of oxygen gas, making 2 moles of oxygen gas. And the product side as well, we have 2 moles of oxygen gas. So this one will cancel it together, this one and this one. So at the end, we are going to remain with carbon solid plus carbon solid plus 2 hydrogen gas. The enthalpy change, to give methane gas, the enthalpy change for this reaction, you also sum the enthalpy changes given. You just use your calculator. Use your calculator. That means you take 890.3 kilojoules per mole plus negative 393.7 kilojoules per mole plus negative 572 kilojoules per mole. You're going to get, when you do that calculation, you're going to get negative 75.4 kilojoules per mole. So you have manipulated the given thermochemical equations to get the required equations, and also you have found the enthalpy change for that reaction. But my dear student, sometimes you can be asked the question, from that given answer, you can be asked the question, is the formation of methane endothermic process or exothermic process? How are we going to answer that question, my dear students? It is very simple. You can just look. The enthalpy change for this reaction is negative 75.4 kilojoules per mole. So I've told you at the beginning, and I'm sure that, my dear student, you are following me. Negative indicates the exothermic reaction. So the process of forming methane is purely exothermic process. Why? Because the change in heat is negative. Negative 75.4 kilojoules per mole. Now, my dear students, I'm sure that from these equations, you can be able to solve different problems relating to these problems using thermochemical questions. As I told you, that most of the students are lacking the skills on how to solve these problems. So it is very, very important. Now, let's go to another example, because I've told you that there are different ways of asking these questions in different examinations. Even in your national examinations, there are different ways of asking these equations. Now, let's go to the second example. Let's go to the second example to see. The second example says, calculate the heat of formation of ethyl alcohol. In other words, it is called ethanol. If the heat of combustion of ethyl alcohol is 1,308.7 kilojoules per mole, and the heat of formation of carbon dioxide and water are given as negative 393.9 kilojoules per mole and negative 286.0 kilojoules per mole, respectively. So that is the second example. And this is the second way of asking these equations. In the first one, you were given thermochemical question. But in this second example, you are not given thermochemical question. You are just only be given the data. What are you going to do? There are skills there that you need to know in order for you to solve these problems. Skills number one. Skills number one from this question. Skills number one, you have first to determine whether the given enthalpy change for the reaction given, are they endothermic or exothermic? I told you from the beginning, and I'm sure that my dear students are remembering, that energetics is all about heat change. So the process can either be endothermic or exothermic. So it is very, very important to determine whether the given reaction with its enthalpy change is either endothermic or exothermic. That is the first thing to do. When you are given the data only, you are not given thermochemical question. For example here, calculate heat of formation of ethyl alcohol. There is a term there for you to understand. If you don't know the meaning of heat of formation of the compound, it will be very difficult for you to solve this problem. So let's see skills number one. In all of that, let's go back to the board. Now, my dear students, let's come back to the question. Calculate the heat of formation of ethyl alcohol. That is number one. There is a skill there. You have to understand the meaning of heat of formation. What is heat of formation if I told you to define? And I'm sure that you know how to define it. Can you define it? And let me remind you, most of the students are facing a lot of challenges in this topic because they don't know how to define energetic terms properly. And that's the problem. If you fail to define these terms, it will be very difficult for you to solve these problems. So the first thing, you have to know the meaning of these terms. So in that question on the blackboard, formation, heat of formation. What is heat of formation? Let's recall back the introductory part. Heat of formation is the heat change. Heat change when 1 mole of a compound is formed from its element in their pure standard states. So what is required? What is required? Heat of formation. Heat of formation of ethyl alcohol. Ethyl alcohol. In other words, ethanol. C2H5OH. That is. So this is the compound which is formed. So when you have the compound, you have to look at that compound. What are the elements constituted in that compound? When you look at that compound, how many elements are there, my dear students? Right there you are. Can you tell me how many elements are there? Okay, let's participate together. Here, there are 3 elements. We have carbon element, hydrogen gas, and oxygen gas. So the 3 elements, when combined together, they react chemically, they form this ethyl alcohol. But these 3 elements, they must be in their pure standard states. Let's be together. How to write it? We have the first one is carbon. The first element is carbon. Carbon is existing as a solid. That is the purest standard state of this element. So we write it as a solid. That is number 1. When this solid carbon element reacts with the second element is hydrogen. You can see. But hydrogen is existing as a diatomic molecule. That means it is existing as a gas. That is the pure standard state of hydrogen gas, hydrogen element. So hydrogen is a diatomic. We have to put here 2. This means a diatomic. That means a gas. A gas. So this is the second one. The third element which is constituting this compound is oxygen. Oxygen also is existing as a gas. It is very, very important for you to understand these terms. If you miss out these terms, also you are going to get a challenge. That's why I'm giving this challenge today, for the problems to be over. Are we together, my dear students? Now, the third one is oxygen, which is existing as a gas. So these 3 elements together, when they react, they form that compound. So to yield ethyl alcohol, that one. And the enthalpy change of formation of this compound is what is required. Now, when you have written this equation, another thing, another skills, you have to balance it. Make sure that you balance it. Just don't rush. Don't rush to solve the problem. Balance first. When we balance, we have 1 carbon on the reactant side. We have 2 carbon atoms. So what you have to do, these are very simple method of balancing. So you just put here 2. We have 2 hydrogen atoms which are present on the reactant side. And on the product side, how many are they? We have 5 here and we have 1 here. So when you plus 5 plus 1, you get 6. So we have 6 hydrogen atoms on the product side. But on the other side, you have 2. Which number will you put here to multiply to get 6? It's 3. So you put here 3. How about oxygen? We have 2 oxygen atoms. We have 1 oxygen atom. What are you going to do? Don't put anything. Remember the definition. 1 mole of the compound, the definition of heat of formation, 1 mole of the compound is formed. So you don't do anything to the compound which is formed. But you have to balance the oxygen gas to get 1. So you put here half. That is a balanced equation. But enthalpy of formation or enthalpy of reaction of this thermochemical question is missing. So that's what we are looking for. So that is the first skill from the first data given there. Now we go to the other data. What are we given? What are we given? Number one, if the heat of combustion of ethyl alcohol is 1,380.7 kilojoules per mole. My dear students, heat of combustion. What is heat of combustion? Sometimes you can be given the data, they are positive, but actually they are not positive. You can be given the data, they are negative, but actually they are not negative. So what you have to do? For example, the heat of combustion. What is heat of combustion or enthalpy of combustion? Are you able to define it, my dear students? If I tell you right now to define the heat of combustion, can you define it? It is very simple, and I'm sure that you have studied in your class. Heat of combustion is the heat evolved or heat released when 1 mole of the compound is completely burnt in oxygen. So, heat of combustion of ethyl alcohol, when this compound is completely burnt in oxygen. Number one, ethyl alcohol is completely burnt in oxygen. That means we have oxygen gas. What are we going to get? And I'm sure that you have the knowledge of organic chemistry because you have studied. All organic compounds, when they burnt in oxygen, we get carbon dioxide and the water. You must have that knowledge from organic chemistry. That's very important. So when ethyl alcohol is burnt in oxygen, we get carbon dioxide gas and water. So the enthalpy change for this reaction is given there, is given as 1,380.7 kilojoules per mole. But my dear student, this data is given in positive. But this is combustion in question. As I told you, combustion in question is the heat released. So this is a purely exothermic process. So you have to put negative here. That was a technique for this question. So as I've told you in the beginning, don't just rush to solve the problem. You have first to think, what are the techniques which are present in the given questions? So that is number one. After that one, you balance the equation. Let's balance together. Carbon atoms present on the reactant side, how many are they? There are 2. How about on the product side? Only 1. So what you have to do? You have to put here 2 before carbon dioxide, and then it is balanced. We go to hydrogen atoms. How many hydrogen atoms are present on the reactant side? We have 5 plus 1, we have 6. But on the product side, we have only 2. So what are you going to do? You just put here 3, because when you take 3 times 2, you get 6. That is a very simple mathematics. For the case of oxygen, we have 3 oxygen atoms present on the left-hand side. And here we have, how many oxygen atoms are present here? We have 2, because the number before the formula multiplies everything. So we have 2 times 2. We have 4 oxygen atoms. That is not already enough. There are 3 also oxygen atoms which are present in water. So when you take 2 times 2, we get 4. And plus 3, we have 7. We have 7 oxygen atoms on the product side. But in this side, we have 3. What are we going to do? We put here 3. To make it 6 plus 1, we get 7. And 2 times 2, 4. And this one gets 7. So for the case of oxygen, is balanced. So this equation is balanced. That is the first given data. We go to the second given data. The heat of formation of carbon dioxide. Heat of formation of carbon dioxide. This is the second one. Carbon dioxide is formed from what? Carbon dioxide is formed from what elements? Carbon and oxygen. And because we are told heat of formation, carbon should be in its pure standard states, and oxygen gas should be in its pure standard states. So here we have carbon, which is solid, that is the pure standard state of carbon atoms, plus oxygen, which is also, the oxygen gas is existing as a diatomic molecule because it is a gas. Now to give carbon dioxide gas. the enthalpy change, the enthalpy of formation of carbon dioxide is given there. The enthalpy of reaction of this equation, reaction equation is given there, is negative 393.9 kilojoules per mole. Kilojoules per mole. Is it balanced, my dear students? Can you tell me, is it balanced? Yes, it is balanced because we have carbon, one carbon on the product side. We have two oxygen atoms, so it is balanced. We go to the last one, to the last data. And the enthalpy of formation of water. Water, H2O, is formed from two elements, hydrogen gas and oxygen gas, in their pure standard states. So the last data, we have hydrogen gas, which is existing as a gas, as well as oxygen gas. These together, when they react, they form water. The enthalpy of this, the enthalpy of formation of water is negative 286.0 kilojoules per mole. My dear students, you have to balance this equation. 2. Remember, when you are talking about heat of formation, 1 mole of the compound should be formed. So there is nothing you can do with the product. You just balance the reactant. So 2 hydrogen atoms, we have 2 hydrogen atoms. There is no problem with that. We have 2 oxygen atoms. We have 1 oxygen atoms. Remember, we're not writing anything here because this is the enthalpy of formation. So we balance here. We put here a half. The equation is balanced. So you can see that is the second way of asking this equation. Now, my dear students, after we have obtained the data, we have clarified our data and the skills from that equation. We go back to our skills that we have started from the beginning. So we have to manipulate these 3 given thermochemical equations to get the required equations. Now, in the required equations, ethanol or ethyl alcohol is on the product side. We will find among the 3, which one has got ethyl alcohol. You find that it is the first one. So what you have to do, my dear students, you have to reverse the equation. So the first thing, reverse equation 1. Equation 1. When you reverse equation 1, you are going to get, that means these reactants would be the product and the product will be reactants. You have to get 2 carbon dioxide gas reacting with 3 molecule of water to give ethyl alcohol and 3 moles of oxygen gas. The enthalpy change for this reaction will also change in sign. So it was negative, now it becomes positive because we have reversed the equation. So here it will be positive 1,380.7 kilojoules per mole. That is number 1. Now, we come to reactants. In the reactant side, we have carbon. You find among the remaining 2 equations, which one has got a carbon atom? You find that it is the second equation. But in the required equation, 2 moles of carbon are needed. But here we have only 1 mole. So what you have to do, as I've told you, are you remembering, my students? That means you have to multiply this equation by 2 in order to get the required one. So multiply equation 2 by 2. So that means when you multiply, you're going to get 2 carbon solid plus 2 oxygen gas to get 2 moles of carbon dioxide gas. And the enthalpy change as well, you have to multiply. Now, use your calculator. I'm sure that you have the calculator there. You take 2 times negative 393.9 kilojoules per mole. And you get negative 787.8 kilojoules per mole. Now, from there, you go to the other reactant, and that is hydrogen. The remaining equation is only 1. Here, 3 hydrogen atoms are needed, but here we have only 1 hydrogen atoms. So what you have to do, you multiply the whole of this equation by 3. So multiply equation 3 by 3, the all of it. So when you multiply, that means you're going to get 3 hydrogen gas plus 3 over 2 oxygen gas to get 3 molecules of water, the enthalpy change as well will be multiplied. So you use your calculator, my dear students. You take negative 286.0 times 3. You get negative 858 kilojoules per mole. So we have already manipulated our data. So from there, what you have to do, you just add the equation together with the enthalpy change, and that is the application of the Hen's law. Now we can clean the blackboard so that we can do that one. Let's clean the upper part. Yes, these are the data. So what you have to do, you have to add these equations together. 2 carbon dioxide gas plus 3 molecule of water. These are the reactants for the first equation. We go to the second equation. The reactants are 2 carbon solid plus 2 oxygen gas. The reactant for the third equation, we have 3 hydrogen gas plus 3/2 oxygen gas. So those are the reactants for the 3 manipulated equations. Now, what are the products? The products here will be the first one, ethyl alcohol. The second one, 3 moles of oxygen gas. For the second equations, we have 2 moles of carbon dioxide. For the third equations, we have 3 moles of water. Now, from there, you sum also the enthalpy change for these 3 equations. The first one is 1,380.7 kilojoules per mole. The second one is negative 787.8 plus. The last one is negative 858. Now, from there, you cancel out those compounds which are present on both sides. Are we together, my dear students? So let's see. Here we have 2 carbon dioxide and 2 carbon dioxide will go. Another thing, we have 3 molecules of water. 3 molecules of water will also be cancelled. Now, what have we remained with? We have remained with the carbon. We have remained with the oxygen. There are 2 oxygen here. So we have to add these oxygen atoms to make 1. So here, just simple mathematics. 2 plus 3/2. What are you going to get here? This is 2, and you are going to get 6. You are going to get, this is 4 plus 3. That means 7/2 oxygen. So we have 7/2. And in this case, we have 3/2. That means 3 oxygen atoms must cancel out because the required equation, we are going to remain with only ethyl alcohol. So you subtract these 3 from here. So you subtract 3. When you subtract it there, what are you going to get? Here is 2. That means 7 minus 3 minus, 7 minus 6. Minus 6 is equal to a half. So you are going to remain with a half oxygen on this side. So here it will be 2 carbon solid plus a half oxygen gas plus 3 hydrogen gas equals to ethyl alcohol. Ethyl alcohol. This one will cancel. Now, the enthalpy change of this reaction, you just use your calculator in order to sum that one. So when you sum, you're going to get negative 264.7 kilojoules per mole. So I am sure that, my dear student, you have got the skills of answering these problems. Now, I hope that we are together in this discussion, and I hope that you have some questions. And this time, I want you to participate with me. If you have any question, this is the time for you to send those questions to me so that we can solve together. Use the number which is displayed and to send the message so that we can go those questions and solve them together. Thank you very much. We'll be back very soon. Stay tuned. My dear students, we are right back. Thank you very much for watching. and I have received some message from different students. Here I have Juma Abdallah from Andeni. How are you, sir? Greetings. I'm appreciating the program. Thank you very much. And also Janet Manyama from Msoma, appreciating the lesson with the skills of solving the problems. I have enjoyed the lesson. Oh, thank you very much. And still some messages are coming. So my dear students, if you have any problem with this one, you can use the number that is displayed there to call me anytime. And I'll be together with you to give the skills on solving those problems. Now, my dear students, remember in today's lesson, we have discussed together some important ideas. The first one, it is very, very important for you to remember the definitions of each energetic terms. If you can't memorize those definitions of those terms, it will be very difficult for you to solve these problems because they are very helpful in solving these problems. That is number one. Don't forget that. But number two, you have to allocate the sign for the given thermochemical data. Because I told you that energetics is all about heat change. So it can either be endothermic or exothermic. So it is very important to check whether the given process, is it endothermic or exothermic? That is very, very important. But also you have to manipulate the given thermochemical equations in order to get the required equations. That is very, very important for you to remember. My dear students, I hope that today's lesson was very, very interesting. And I want to take this opportunity to thank you for watching this program. Now, let's take this opportunity to welcome you in the next program. Hope to meet you next time. Thank you very much for this time.